for second class transmission distribution class 2. Today's topic I'm talking about inductance of a conductor. Inductance of a single phase two wire line. It's very important. Consider a single phase line which has two parallel conductors. These conductors are forming a rectangular loop of one form. See, these conductors, whatever I have written here, are forming a rectangular loop of one turn. These conductors are solid conductors of radii R1 and R2. One conductor is forming a written circuit for the other. The two conductors are carrying current I1 and I2. It's not shown here. The two circuits what I have written here, that's carrying current I1 and I2. So in a single phase circuit, we have I1 plus I2 is equal to 0, I2 is equal to minus I1. See here, this is one circuit and this is one circuit. Here each one has resistance radius R1. This is having a radius R2. Now here we are neglecting the effect of Earth's presence of magnetic field geometry, as Earth's relative permeability is same as that of air and its conductivity is also relatively very small. That's why the arrangement of the conductors and variation of flux density due to each conductor I will show here. Okay, this is now again let me write. Now from here to here I am calling it as D minus R2. From here to here I am calling it as D minus R2. Then from this part to this part, from this radius to this radius, I am calling it as capital D. And next one is D plus R2. From here to D plus R2. You can only tell where R2 ends. Here, okay. These are the conventions I'm using. Now, here in the beginning, let us consider only the flux linkages of the circuit caused by the current in conductor 1. Okay, this is conductor 1 we are considering like that. The flux line set up by that current flowing in conductor 1 at a distance equal to or greater than D plus R2 from the center of conductor 1 does not link the circuit and hence is not responsible for inducing any voltage in the circuit. Hope you understood. This is because conductor 2 carries current which is equal and opposite to that in conductor 1. Therefore, the external flux from R1 to D minus R2, links all the current I1 in conductor 1 over the surface of conductor 2, that is between D minus R2 to D plus R2. The external flux links a current whose magnitude is actually or progressively reduces from I1 to 0 because of negative current in conductor 2. Therefore, the total inductance of the current carrying conductor in conductor 1 can be calculated assuming that D is much greater than R1 and R2. These are the assumptions you have to keep in mind. Under this condition, it can be assumed that flux from D minus R2 to the center of conductor 2 links current I1 and flux from the center of conductor 2 to D plus R2 links zero current. So, the inductance due to here The inductance, let me start from the first here. The inductance due to that I will call it as L12. Okay, the inductance, this is due to the current in conductor 1, can be calculated by using this relation. L12 is equal to 2 into 10 raised to minus 7 into ln of d2 by d1 Henry per meter. Okay, this expression is valid for external flux only. For internal flux, it becomes L1 internal. L1 internal is equal to half into 10 raised to minus 7, half into 10 raised to minus 7 Henry per meter. So, doing all these equations, the above equations can conveniently be written as L1 is equal to L1 internal plus L12. When I add that, I will get L1 is equal to half into plus 2 ln into d by R1 whole to the power 10 raised to minus into 10 raised to minus 7 Henry per meter. Now the above equation can conveniently be written as L1 is equal to, you can write it as L1 is equal to 2 into 10 raised to minus 7 into ln of e to the power 1 4 e to the power 1 by 4 into ln of d by R1, where ln e to the power of 1 by 4 is equal to 1 by 4, that you can substitute and get the final relation as 2 into 10 raised to minus 7 into ln of d divided by e raised to minus 1 by 4 into R1. This is L1. Similarly, you can find the inductance of conductor 2 in comparison with this equation you can also write. So comparatively, if I write, L2 becomes 2 into 10 raised to minus 7 into ln of d by R2 dash Henry per meter. So this is about inductance. The above equation gives the inductance of two wire single phase line, taking into consideration the flux linkages caused by current in both the conductors. So let us wind up the class 2 now.